various features like core pinning and platform optimized compilation. And now we are, with this background of CEP and InfoSphere streams, I think we are ready to dive into the solution, which is a real-time capital market surveillance solution. We felt the need because the rate at which the capital market transactions are generated is extremely fast, often going up to more than 1 million messages per second. Traditional approaches of storing the data in a data warehouse and then processing it via statistical analysis and data mining is often inadequate because the data rates are very, very fast. So the amount of data accumulated and analyzed is also very, very high. So the problem of surveillance of fraud detection on streaming market feeds can be addressed through the efficient use of the stream processing engines. So capital markets and its surveillance, what it entails. In a capital market, investors and all sorts of market participants expect a transparent, influence-free open market for trading stocks, options, commodities. The responsibility to ensure that the above happens lies on the exchanges where the instruments are traded. Now, these particular authorities are guided as per the laws of the land. But there is a history of market manipulations because since the inception of these kinds of markets, there has been newer ways being found by market manipulators. So capital market surveillance has become the highest priority activity for the exchanges and regulatory authorities. So in modern world, especially in the modern world, where all financial transactions happen electronically, either through web-based systems, algorithmic trading. So what this has enabled is many people to perform trading in the capital market. As a result, huge amount of data gets generated from various sources, and the rate of generation of the data streams is very, very high. Therefore, it's high volume, high velocity. There's a pressing demand to detect market manipulations by identifying the anomalies as fast as possible to avoid losses and faith in the markets. So we want fraud detection in a near real-time mode. On the other hand, while the techniques or algorithms for such detections are available to the authorities, but there is a constraint for executing them in stream and real-time data. And the DSMS platform or the stream processing engine is an answer to this particular problem, real-time problem of the market. Here I have just listed a few of the manipulative practices which are prevalent. So if we see how monitoring or trading activity in an exchange is done, it basically consists of a system, a stream processing engine that takes as input all the orders that are being placed by market participants. These orders are executed or retained depending on the policy. And other track, there is one track which executes the order and there is another track which cancels the order. The outputs of these two tracks are then put into a stream called the executed order stream or the cancel order stream. And these two streams are then input to a correlation engine that matches the executed and the cancelled order from the same participant and accumulated the matched values for specific time windows, say X days or Y hours. And whenever the ratio, say, of total and cancel to total and executed exceeds a particular threshold, an alert is generated. So basically, it is doing things offline. But what we are doing is we are trying to propose a solution which will do the same thing in-stream. So it's in-stream analytics at microsecond level latencies and at high performance. So there are multiple rule-based engines which we have evaluated, and the chosen platform was IBM InfoSphere Streams, and we integrated it with Cognos real-time monitoring for real-time dashboarding and continuous monitoring. Also, automated alerting. See, the overall solution approach was we had the input stream of transaction data, input stream of other related data from the markets, Then the input was also from the historical database of the transactions, and the streams engine, which processed these manipulative practices real time as the data is flowing in. So we had complex queries written for the scenario selected, and the InfoSphere streams processed it, and it gave alerts or it gave real-time dashboards. The development platform was an Intel-based server with quad-core with Red Hat Enterprise Linux 5.4, the latest version of Streams 2.0.04, and database was open source MySQL with 2 reporting tools explored, GNUplot and Cognos RTM. See, we picked up for the initial scenarios the most commonly used manipulative practices, which are listed here. The long gap with last traded date, anomaly in average trade price, anomaly with respect to normal parameters, high-low variation, price variation, consecutive trade price variation. So these are the ones which we had done initially, and on top of that, we added multiple scenarios from the different market clients. So the solution was customized as per the market clients. So this is the example which I had said, where there are multiple logins coming in and multiple people placing orders at the same time, executing the order, some people canceling the order. So when the maximum order withdrawal for a particular customer exceeds a threshold, that's when we revoke that customer. We immediately alert the capital market or the exchange, saying that there is a fraudulent activity going on, and that arrests that particular activity right in time to avoid any further mischief. So some of the results which were recorded is, it was for the time for InfoSphere streams and this particular solution was for a tuple for record was done within 2.3 to 8 microseconds. So we had multiple found out that about 2.38 million transactions were processed within 20 microseconds. So it is a very, very high latency, low latency result, and this is what is the need of the hour, which is a real-time analytics. So from the statistics which are presented, we concluded that 99% of the stream tuples were processed within 10 microseconds. So some of the delays observed were due to maybe the Linux processes running and slowing down the process, but overall it was each and every tuple was processed within 10 microseconds. This gives you the graphical representation and with the GNUplot and the Cognos real time. The first one gives the price variation related alerts, and for 2 stocks, and the other one gives you points where the alerts are generated. These are the other additional scenarios we are working on with the client, and the solution can be customized